Welcome to Sundar's lecture. This is lecture number 38, and in this lecture we are going to see AC through pure capacitor, right? And then we are going to derive the expression for power in the capacitive circuit, right? What are all the topics we have seen in the last class? See, we have taken AC through pure inductor in the previous class, and we have derived the expression for current in the inductor, which means purely inductive circuit when AC supply is given. Then we would have found what is the power in the inductive circuit, purely inductive circuit, and we have found that P is equal to minus Vm Im by 2 into sine 2 omega t, right? So with this power expression, we have plotted the graph for the different omega t values, right, from 0 to 360 degree with the 45 degree split ups, and we have finally concluded that the AC power in the purely inductive circuit is a reactive power. See, if you take average for this power, for this curve, you will get obviously 0. So 1, 2 minuses are there, 2 pluses are there, under 2, 0 to 360 degree, everything will be cancelled each other, and you see the power is flowing from source to load, load to source in this portion, and in this portion it is source to load, and then it is actually oscillating between the source and load. The power is oscillating between source and load. It is not utilized by the load or by the source. So that is the power we are calling. Those powers are reactive power. See, and then in this class we are going to see AC through pure inductor, pure capacitor. So if you need to find what is the current in the inductor, right? So that is our ultimate aim. Then we will multiply the current with the voltage to get the power expression, and we try to draw the graph in the next portion, right? So see, if you want to find what is the current value, first we need to find what is the value of charge in the capacitor, Q, which is equal to C into V, right? That we know already. These kind of expressions were already derived, and you would have studied these kind of expressions in the basic physics, right? Q is equal to C into V. So this expression can be further right, C into what is the voltage here we are giving. So that is nothing but it is Vm sine omega t, right? This is the voltage we are giving here. So Q is equal to C into Vm sine omega t is the expression. And what is the I value? We know this one, right? I will be is equal to dq by dt, right? Change in charge, rate of change of charge with respect to time, that is nothing but we are calling it as current in a capacitor, right? What we need to do, so we need to differentiate this expression with respect to time, right? So this will be C into Vm sine of omega t, right? We need to differentiate this expression, that's all. We need to differentiate this expression. So if you differentiate this expression, what you will get, so C is the common term, so you take it outside. So and also Vm is the common term, that also you have to take it outside, and you see you need to differentiate sine omega t with respect to t. So you will get cos omega t, and you need to again differentiate this whole term, that is omega t, what you will get into omega, right? That is the final expression you will get. So in this expression, what I will do, see C omega Vm cos omega t, that is the final expression. And what I am going to do, I am just going to take the C omega to the denominator side, so that I will get, see, I will write this expression like this, I which is equal to Vm divided by 1 by omega c, right? I will write like this, 1 by omega c into cos of omega t, and also we can write this one, right? Vm in I is equal to Vm divided by xc, I am taking it as xc cos of omega t. And also what is now xc? Xc here, xc will be is equal to 1 by omega c, right? What is omega? We have already seen this, right? 1 by 2 pi f into c. And what is this xc? Which is nothing but it is capacitive reactance. Capacitive reactant, which means, see, this is in the denominator, right? Xc, which is in the denominator, so that this is the opposite passage for the capacitor, flow of current in the capacitor, opposite passage, which means, right, it is like a resistor in a resistive circuit. In a current, if you want to find what is the current in the resistive circuit, then you will get Vm divided by R. What is that R? That is the opposition path created by the resistor to the flow of electrons in the resistor. Here it is the capacitor. So I am just writing it as capacitive reactance. So finally I can be written as Im cos of omega t. What is Im? We can directly write what is Im? Im, which is equal to Vm by Xc. Vm by Xc. So this is the final expression of current in the capacitor. So current in the capacitor can be written like this, right? Now we can go for the power. Right? So how will you find power? Power expression we know already. Power, which is equal to V into I. What is V here? What is V here? V is equal to Vm sine of omega t. That we know. Into Im cos of omega t. Right? We have found this now. So what is this one? Sin A cos A. We have already seen this. What is sin A cos A? Sin A cos A can be written as sine of 2A divided by 2. We know this expression, right? So what we can do now? So finally we can write it as Vm. This will be Im, and instead of sin A, here we are having omega t, right? So sin A and cos A. So how I can write this expression? So sine of 2 omega t divided by 2. And at last, finally, I can write, power can be written as Vm Im by 2 sine of 2 omega t, right? So this is the final expression for the power in the capacitive circuit. Now you compare this power expression with the inductive circuit, right? You see, what is the power expression we have got in the inductive circuit, purely inductive circuit? It is minus Vm Im by 2 sin 2 omega t. The same expression we are getting here in the positive value, right? That is the only difference. That is the only difference we can see here. So what we are going to do? We are going to substitute the omega t values from 0 to 360 degree, and we try to plot the graph for the expression we have got in the purely capacitive circuit, right? See this one. I have just taken this expression, that is Vm Im by 2 and sin 2 omega t. That is what we have derived, and I have just substituted the omega t values. It is 0, 45 and 90 degree, right? So we have seen this one already, so it is not necessary to go very deep into this. So we try to plot this diagram now. So this is the omega t values. At 0 it is getting 0, right? So at 0 we are getting 0, so it will be like this. And at 45 degree it is Vm Im by 2. So at 45 degree it will be Vm Im by 2. So it will come around here. And again in the 90 you will get 0. Again at 90 you are getting 0. And at 135 you are getting minus Vm Im by 2. So minus Vm Im by 2 at minus 135 degree. And at 180 degree again you are getting 0. So I am just plotting this curve. You try to cope up with me. So at 225 degree again it is getting maximum Vm Im by 2 in positive direction. And at 270 degree again it is getting 0. So it will be here. And at 315 degree we are getting minus Vm Im by 2. So at 315 degree I am getting minus Vm Im by 2, and at 360 degree again you are getting 0. So this will be 0. So now I try to connect all the points. See, we are just connecting the points, that's all. See, this will be connected like this, and this will be like this. Now you see the expression. Now you see the graph here. Here we are getting the positive. Here we are getting positive, and here we are getting negative. Again you are getting positive power. Again we are getting negative power. and this will continue forever, right? That those kind of things and all we have seen already. So here also the power flows from source to load, load to source, source to load, load to source. Again it is oscillating. No power is only at the positive region. So obviously all these powers are again here is the reactive power, right? Reactive power, right? We have seen this one already, right? And if you take average, what you will get? P average will be what? Since it is the positive curve up to 90 degree and 180 degree it is getting negative. Again it is at up to 270 degree it is getting positive and negative. So if you take an average from 0 to 360 degree, obviously you will get a 0. 0. Then there is no real power. Obviously, this is nothing but real power, right? Real power. There is no real power in the pure capacitive circuit. Very simple, right? You can easily get these kind of things easy to understand, right? So this is the real power, reactive power. Only we are getting the reactive power in the purely capacitive circuit. Now what we do, we try to draw the phasor diagram. How will you draw the phasor diagram? So phasor diagram, phasor diagram. So first we write what is Vm. First I will write what is Vm. Vm, sorry, V, not Vm. So what is V? V will be is equal to Vm sin omega t, and what is I? I will be is equal to Im cos of omega t, and what I can write, see, cos omega t can be written as sin of omega t plus 90 degree, right? I can write like this, right? So what is I know? I can write I is equal to Im sin of omega t plus 90 degree. See, it is right now. We can write like this. So we will go to the next page to get this value. See, I just need to draw the phasor diagram, right? Phasor diagram. So if I draw the phasor diagram, so this will be the x-axis, and at x-axis I am just getting this value, and maybe okay, fine. This value, what is this value? This is nothing but V. And what is V? V will be is equal to Vm sin omega t. That is nothing but it is the reference value. I have told you already. Wherever you see Vm sin omega t, that will be the reference value. We always take reference values, right? It is nothing but it is Vm sin omega t. And what is this one? This current is actually leading the voltage by 90 degree plus 90 degree. So it is nothing but it is leading. We have seen already what is leading phasor, what is a lagging phasor. So if it is leading phasor, what you need to do, you just try to draw this one in this way. So this will be Im. This will be I, and Im will be is equal to Im sin of omega t plus 90 degree. And what is this angle? This angle will be 90 degree, and that is nothing but we are calling it as phi. See, you can conclude here that if it is a purely capacitive circuit, then the power in the circuit will be reactive power. All the powers will be reactive power, and the current will leads the voltage by 90 degree. Simple to understand, right? If it is a inductive circuit, current will lags the voltage. You see here, current will lags the voltage by 90 degree. And if it is a purely capacitive circuit, and here also power will be reactive power, and here power will be reactive power, but current will leads the voltage by 90 degree. So these are all the things. So in the next class we will see the new topic with RL RC circuits. Thank you. We will see in the next class.